Hello, everyone. Welcome to Elitesgrid. So we are back with another RC. So let's start reading it. An example of a scientist who could measure without instrument is Enrico Fermi, a physicist who won the Nobel Prize in Physics in 1938. He had a well-developed knack for intuitive, even casual sounding measurements. One renowned example of his measurement skills was demonstrated at the first detonation of the atom bomb at the Trinity test site on July 16th, 1945, where he was one of the atomic scientists observing the blast from the base camp. While final adjustments were being made to instruments used to measure the yield of the blast, Fermi was making confetti out of a page of notebook paper. As the wind from the initial blast wave began to blow through the camp, he slowly dribbled the confetti into the air, observing how far back it was scattered by the blast, taking the farthest scattered pieces as being the peak of the pressure wave. Fermi concluded that yield must be greater than 10 kilotons. Now, what we have studied till now, we're talking about a scientist, Enrico Fermi, and we're discussing how he has a very good caliber for measuring certain things that may not be very easy to measure. और एक हमें example दिया, basically an event of his life where he was the part of the team who was testing the atom bomb. So he was at the base camp, but then also, when people were making certain adjustment, that time he just, from a notebook paper, he made confetti, small pieces of paper. And, because of the blast, those small pieces, they were scattered far. Now, by looking at, how far the piece has gone, so how far it has been scattered, he made certain judgments, certain estimation about the, that yield must be greater than 10 kilotons. So how far that piece was scattered, he made certain estimation about the measurement. This would have been new since other initial observers of the blast did not know that lower limit. After much analysis of the instrument readings, the final yield estimate was determined to be 18.6 kilotons. Like Eratosthenes, Fermi was aware of a rule relating one simple observation: the scattering of confetti in the wind to a quantity he wanted to measure. So, based on how far that piece of paper has gone, उसके basis पे he concluded that at least, minimum इससे ऊपर तो yield होगा. And in reality, it was definitely above that. So somewhere his estimation was correct because he assumed that it would be greater than 10 kilotons or asli में भी 18.6 मिला. So it was just, he's being compared to another scholar, and then how he could relate scattering of that small piece of paper to a quantity about the yield of the atom bomb. So अभी तक हमने यही पढ़ा है कि how this scientist is having a good caliber for measuring certain quantities, not really measuring but estimating them when they cannot be really measured. The value of quick estimates was something Fermi was familiar with throughout his career. He was famous for teaching his students skills at an approximation of fanciful sounding quantities that at first glance they might presume they knew nothing about. The best known example of such a Fermi question was Fermi asking his students to estimate the number of piano tuners in Chicago. When no one knows the answer, his students, science and engineering majors, would begin by saying that they could not possibly know anything about such a quantity. Of course, some solution would be to simply do a count of every piano tuner, perhaps by looking up advertisements, checking with a licensing agency of some sort, and so on. But Fermi was trying to teach his students how to solve problems where the ability to confirm the results would not be so easy. He wanted them to figure out that they knew something about the quantity in question. So again, we are talking about his ability to estimate things or estimate certain quantities even when you do not know about them properly. So one example is given that when he was teaching his students, so he asked a question: how many piano tuners are there in Chicago? Now, definitely students were not knowing it. So, but there were things that, yes, which we can do to know, for example, by seeing the advertisement, maybe we can calculate, or maybe there is some licensing agency which gives license to those piano tuners, so maybe through that we can get. So these are some examples that through which we can come to know. But the main focus was not that you would actually count. The main focus is how do you estimate about something when you do not know how to measure, or maybe that thing that you are measuring is really difficult. So that is the main thing. So the main core aspect of the passage is that we are talking about a person and how he is through his knowledge, we are studying that how things that are very difficult to measure can also be measured estimately. We can get some approximate value for them. So पहले bomb blast वाला example दिया था कि through using small pieces of paper he could estimate कि क्या yield होगा, और reality में उसके near ही था. And then his another example is given, like for example piano tuners and how he was teaching his students and all. So this is the main thing, that you can make an attempt to estimate a thing without really knowing the exact value. Let's see the questions. Suppose you apply the same logic as Fermi applied to confetti, which of the following statements would be the most appropriate? Okay, so the same logic that was applied to confetti. Now, we remember what was the thing कि atom bomb के blast से जितनी दूर तक, because of the wave, those small pieces of paper, they were scattered. तो जो जितनी दूर तक है उससे फिर उसने अंदाजा लगाया कि मिनिमम इतना तो होगा, इससे ऊपर का ही होगा, इतना तो मतलब based on that location कि इससे ऊपर ऊपर मतलब somewhere he was trying to estimate कि कितना yield होगा based on the how far that paper has traveled. Let's see the options. You can calculate the minimum pressure inside the cooker by calculating the maximum distance traveled by any of its part after it explodes. Yes, if this is like really sounding very similar to the given example, because उसमें भी जैसे कुकर के अंदर कितना प्रेशर है, हम कैसे कर रहे हैं by seeing how its parts have traveled after it explodes. तो वो जो उसके different parts है वो कितनी दूर तक है. Just like example में वो pieces of paper थे, उन्होंने कितना travel किया, इसमें हम देख रहे हैं कि जो parts थे एक्सप्लोजन के बाद वो कहां तक गए हैं. एंड जैसे इसमें था कि बेस्ड ऑन हाउ फार दैट पीस ऑफ पेपर हैज ट्रैवल्ड, वी आर सेइंग इससे ऊपर तो प्रेशर होगा, इससे ऊपर तो यील्ड होगा ही, एंड अकॉर्डिंगली वी आर मेजरिंग मतलब इतनी दूर तक पीस गया, मिनिमम इतना प्रेशर तो होगा ही. सो समवेयर द लॉजिक इज क्वाइट सिमिलर, बट लेट्स सी अदर ऑप्शंस. You can calculate the average potency of a firecracker by calculating the distance covered by one of its bigger fragments. The thing is, we were not calculating average. हमने एवरेज वैसे भी वी आर नॉट रियली टॉकिंग अबाउट कैलकुलेटिंग एवरेजेस हियर, वी आर टॉकिंग मोस्ट अबाउट अप्रोक्सीमेशन हियर. सो द एग्जांपल दैट इज बीइंग गिवन टू अस, इट वाज लाइक द यील्ड मस्ट बी ग्रेटर देन दिस. तो मिनिमम वैल्यू कैलकुलेट कर रहे थे बेस्ड ऑन हाउ फार दैट पीस has been scattered. So we were not talking about average, but rather the minimum. मतलब इससे ऊपर तो होगा, इतना तो है. So we can eliminate B. C, you can easily find out the average potency of an earthquake by measuring the length of a crack it makes on the surface of the earth. Again, average की बात नहीं हो रही है. We are again talking about, he did not calculate average, he just calculated the minimum value कि इससे ऊपर तो होगा ही. So again, we cannot really take this option as correct because it's again talking about average. You can calculate the exact volume of water stored in a tank by measuring the distance covered by the stream of water coming out of the tap fixed on the lower corner of the tank. Now, issue with this option is exact volume of water नहीं. पूरे passage में हमने कहीं नहीं पढ़ा that you have to calculate the exact values. We are talking about estimations, that estimations can also be a good way to know something when you can't really measure the exact quantity. So exact thing की बात हम लोग पूरे passage में नहीं कर रहे हैं. So we can eliminate it. So the answer is A, that yes, just like how far the piece of paper has traveled, he calculated minimum इतना yield तो होगा, इससे ऊपर ऊपर है. So similarly, A is saying that because of the parts of the cooker, how far they have traveled, we are calculating the minimum pressure inside it. So that is the logic. Answer is A. Quick estimate as per Fermi is most useful in finding an approximate that is more useful than existing values. The thing is, yes, it is useful for finding an approximate, but this sentence which is saying it is more useful than existing values is something not really making this option appear appropriate, because we have not really discussed on this aspect in the passage. In finding out the exact minimum value of an estimate, see, entire passage you never have to talk about exact. It is actually opposite of exact. We are focused on finding rough estimates, close approximations. That is why he said must be greater than this. He could not find exact value. And that is why piano tuner se bhi we are actually finding the estimate value ki thoda ad se ya licensing agent se pata chal sakta hai. You can't really calculate the exact value. So passage is absolutely, against exact ki koi baat nahi ho rahi hai. So we can safely eliminate option B and C because the passage is not about exact. It is about, estimation. So exact minimum value या exact values find करना goal ही नहीं है पूरे passage का, so we can eliminate them. D, in finding out the range of values of an estimate, range of values means yes, approximately, it would be bigger than this, it would be lesser than this. Just like this example, it was talking about greater than this. Somewhere we're talking about range. So, out of the other options, only this option is looking more appropriate because B and C we can eliminate because of the exact word, or jo A mein likha na, which is more useful than existing values, is not really going well. So we can safely go with D then because it is talking about, again, rough range is like you don't know the exact value, but definitely a rough estimate, which is the core theme of the passage. So answer is D. Given below are some statements that attempt to capture the central idea of the passage. Okay, the central idea of the passage. It is useful to estimate even when the exact answer is known. No. This is the issue. It is useful to estimate, yes, but when you cannot know the exact answer, not when the exact answer is known. When you know the exact answer, there is no point of estimation. So this is not as per the passage. This is absolutely irrelevant. We can eliminate it. So one option hai nahi, so we can eliminate this option that contains A. It is possible to estimate any physical quantity. Yes, you can estimate anything physical, which that is why they have given different examples that you may not know the exact value, be it, the yield of the atom or be it the piano tuner's number. But the thing is, we can make an effort to find the approximate or estimation. So 2 is all right. Anyway, 2 is there in all the options. So it is definitely correct. It is possible to estimate the number of units of a newly launched car that can be sold in a city. See, yes, apne aap mein this statement is correct that it is possible to estimate. But the thing is, I have to see if it really is part of the central idea of the passage. The question is not asking you which statement is correct and which is incorrect. It is asking you which is the central idea of the passage. Central idea ये नहीं है कि how many things, how many cars can be calculated. अगर हमें piano tuners का example भी दिया था, तो it was to show it as an example for the core thing. Core thing is that we can estimate. We can calculate estimates of various things. And then, as an example of that, this thing was given. This is not the main thing of the passage. ऐसे बहुत बार होगा, बहुत passages में ऐसे होता है कि कोई एक sentence या कोई एक example जो passage में mentioned है, वो option given होता है. And then you think, yes, it was mentioned in the passage. But the thing is, it is not about, whether that thing is correct or not. The thing is it the core theme, the most important thing, which is the central framework जिसके अंदर बाकी चीजें fit हुई हैं. तो इसलिए it is not really the core theme. ये पूरा passage का सबसे important idea ये नहीं है कि हम लोग cars calculate कर रहे हैं, कैसे कर सकते हैं, newly launched. That is not the thing. So we can eliminate it. Fermi, so we can eliminate 3 also. So this option also has 3. This also has 3. So it's over actually. We are left with only one option, but let's check statement 4th also. Fermi was a genius. See, yes, the passage somewhere gives you example that how Fermi was able to calculate. But the thing is that is not the main thing. सिर्फ Fermi की ही पूरे passage में हम बातें नहीं कर रहे हैं कि वही best है, he's a genius. We are more or less, talking about that how we can estimate things, we can get approximation of the quantities that cannot be measured that time. So that was a thing. And anyways, once you eliminate 3 and 1, तो ये सब options चले ही जाएंगे. You will be left with D only. And 2 is actually the most appropriate statement. Yes, this is the central idea of the passage, that it is possible to estimate any physical quantity. और फिर इसी बात के लिए उन लोगों ने Fermi को use किया to show that he was able to do it and he used to teach his students how to do it. But it's not that, we are only praising this person. We are just, singing songs of his praises and nothing else. So ऐसा भी नहीं है कि the entire thing is just to prove that this person is a genius. The purpose is to show that you can estimate things, and that is a way, for me was a way to explain that how this person was doing. That is what the main thing was, key, how you can estimate physical quantity. He was given as an example that, how atom bomb blast, maybe he calculated the rough estimation, then how when he was talking about this to his students. But the entire thing was not कि वो genius, otherwise सिर्फ उन्हीं की बातें होती, हम एक इस टॉपिक पे नहीं होते, पूरा पैसेज इस टॉपिक पे रिवॉल्व कर रहा है। अगर ये होता कि ही वाज अ जीनियस, तो फिर हम शायद उनकी अलग अलग अचीवमेंट्स, अलग अलग टॉपिक्स के बारे में बात कर रहे हो, तो वो नहीं किया है हमने, right? When he was born, he was like this. When he started teaching, he was like this. He became scientist, was like this. We're not focused on his autobiography. We're more focused on the concept of estimating things. That is why, only second statement is correct. So answer is D, 2 only. Read the statements given below. Atomic bomb detonation was a result of Fermi's Nobel Prize contribution. Fermi's students respected him as a scientist. Yield of atomic bomb can only be measured in kilotons. Which of the following statements can be inferred from the passage? See, this is an extreme, very extreme. Yield of the atomic bomb can only be measured in kilotons. ये ऐसे कहीं हमने बात नहीं की. Yes, when we were talking about this example, तो हमने इस example में जो unit use की थी वो kilotons थी. But इसका मतलब ये नहीं है कि no other unit can be used. And passage is not talking about it. So we can safely eliminate कि नहीं, third is not something which we can infer. So this option gone and this option gone. Fermi's students respected him as a scientist. The thing is, we are not given any information about how students respected him or what kind of regard they held for him. What we are given is that he was teaching. We are only told that Fermi used to teach skills of approximation to students, and he was famous for this particular thing, that he would teach you how to approximate things. Beyond that, we are not really given whether they respect him as a scientist, whether they respect him as a friend, whether they respect him as like what, or they didn't even respect him. They just listened to his lecture because they really find it useful. So we are not given any information about it. So we can eliminate this also. Atomic bomb detonation was a result of Fermi's Nobel Prize contribution. Nobel Prize contribution की वजह से ये नहीं हुआ था. Just because your contribution won Nobel Prize, it really doesn't mean that your atom bomb, that event was because of it. So yes, these two things happened, that he won the Nobel Prize in 1938, and that atomic bomb thing happened in 1945, but passage is not saying it happened because of this. ऐसे कुछ हमें बताया भी नहीं हुआ. It's just that we are told कि that he won Nobel Prize in physics, that's all, and then we are talking about another event. तो कोई इनमें cause effect relationship passage में नहीं given हुई that this was a cause for this or that. So we can't infer it automatically. We are just given it as separate information that he won this prize, and then we are talking about another event in his life. There is no big connection being drawn here. So we are not talking about any cause-effect relationship, that it was a result of this. We are mentioned that, we are given that, yes, this thing happened, and we are given that this thing happened. But what really led to this, or they caused, what was the cause effect? So we are not given this. So we can again say we can't infer this. So answer is D, that none of the 3 statements is correct, right? So yes, it's not that you can only measure it in in kilotons, not given, and what kind of respect he got, not given, and the cause effect relationship between them is also not given. So answer is D. Now this passage is over. I hope you would have understood it well, and then we'll be back with another passage soon. Thank you.